Good afternoon, colleagues. This is the T1S1 session, Water Scarcity, Space Technologies to Monitor Precipitation, Soil Moisture, and Drought. I'm Jorge Gutierrez from FAO in Colombia, and it's my pleasure to present Mr. Freddy Angel Soria. Mr. Soria is a civil and environment engineer with interest in environment health, water, sanitation, and remote sensing technologies. In support to that, he currently works at the Universidad Católica in Bolivia. The name of the presentation is Water Stress from the Andes to the Amazon using SPEI, Global Drought Index data, and ecosystem space-borne thermal radiometer. Thank you so much and welcome.
Thank you so much. I'm very happy to be here, very happy to have such a beautiful audience and in such a beautiful country. And as my colleague said, my name is Freddy Soria. I will present a short work on observations related to water stress using some drought index, SPEI, and water use efficiency index also. Oh, thanks. During stressful situations, usually the responses of plants is to try to close the stomata in order not to lose too much water because of that situation. But there's also a cost in terms of carbon uptake by photosynthesis. So the questions I will try to respond, perhaps not in full, but at least I will try to wake your motivation or your curiosity. It will be first how plants will respond to a change in climate with changes in temperature, precipitation, and mainly carbon dioxide, CO2, and how will plants respond when extremes such as droughts will hit them. That's what I will talk about today. So into that topic, I will try to guide you through a journey that goes from the Andes at about 4,000 and a little bit more meters above sea level. And we will go down up to the Amazon basin at about 300 to 200 meters above sea level. So I will try to show you how would plants respond with varied geography with observations from satellite platforms. So there's one concept I will use during my presentation. The concept is named water use efficiency. It has been presented briefly by Nina in a previous talk. And the concept I will focus on will be not exactly on the ecosystem water use efficiency, which relates the ratio of carbon assimilation to water evapotranspiration of an ecosystem, but I will focus on plant water use efficiency, which is the total biomass produced by unit of water consumed, or in other words, the ratio of grams of carbon that plants take in 2 kilograms of water that plants release. Grams of carbon per kilograms of water. Well, in a climate change context, the issue is that when levels of CO2 rise in the atmosphere, plants try to adjust to that, as I said, by using the less water as possible while also taking up CO2 during photosynthesis, as I said. But one of the issues that arise from that is that due to global warming, plants tend not to use much water. Plants try to, of course, take up as much as carbon as possible, but it has some limitations. So that's one of the issues I will try to cover today. The importance from a practical perspective, well, there are several aspects that we could evaluate, but I will try to focus, at least in these few minutes, on what would happen when we try to solve or we try to overcome these issues through nature-based solutions in order to promote carbon sinks, of course, to take up those emissions that we generate through our activities, and that's me. So the methods are pretty simple. I have used a standardized precipitation evapotranspiration index, the SPEI, which is a widely known index. I have used also water use efficiency data from the ecosystem spaceborne thermal radiometer experiment on the space station, EcoStress. And I have tried to analyze that data using not so complex algorithms. In this case, I have used unsupervised machine learning techniques from the k-means and hierarchical clustering perspective. On the results part, I want to show you only two parts of what I have observed using those platforms. First, on the upper part are the results from the observations made on the semi-arid areas of the country. As I said, from 3,800 meters to 4,000 meters above sea level, where the vegetation is characterized by herbaceous and sparse shrubs, and droughts that hit that region are from moderate to severe with different durations. As you can see in the graph above, the SPEI has different scales comparing the one in the upper part in the highlands to the semi-tropical lowlands. As smaller the number, then the droughts will be more bad. And in the case of the lower figure, it shows how the droughts will hit a semi-tropical lowland. In this case, of course, droughts will be from severe to moderate in both cases, but the duration will be different. But what about the water use efficiency? In both cases are quite sparse, quite diverse. In the case of the highlands, it can reach up to 1 gram of carbon per kilogram of water. But in the case of the semi-tropical lowlands, as you can see in the y-axis in both figures, it can reach values higher, from 0 to 2 grams per carbon per kilogram of water. What means that for example, when that kind of areas in the lowlands are affected by deforestation or any kind of activities caused by man, then the effects or the impacts will be higher in terms of carbon uptake, for example, among others. So what happens between the associations between water use efficiency, which is the index I've been showing to you in the previous slides, and the occurrence of, for example, extreme events such as droughts? As you can see, there is no linear relationship. The relationship that we have found in the Latin American area, which I'm showing in the figure below, couldn't be repeated in other parts of the world. In some areas, you could find negative relationships between the water use efficiency index and the drought indices in dry areas. In other regions of the world, you can find some positive relationships, or in some other areas, you can find, for example, in zones with high humidity, positive and at the same time negative relationship. So there's no direct or linear relationship between both kind of indexes. As I showed you before, in Bolivia, the associations are also quite mixed, where you can find water use efficiency, for example, in the low semi-tropical areas from 0, similar to the ones you find in the upper part, in the semi-arid zone of the country, up to 2.5, and that's the difference. You can find in the low part vegetated areas which might be better in terms of trying to tackle the effects of climate change or trying to uptake carbon sources as it should have been expected because of the density of the vegetation and others. From other perspective, when vapor pressure deficit, for example, increase in case of hotter or even drier conditions, that could stress plants and causes them to consume more water, lowering their water use efficiency, which in this work has been translated as a tendency of plants in those semi-tropical areas which can produce more biomass and can consume less water. We're having their water use efficiency that can be as low as in other parts where the vegetation is quite sparse, similar to desert areas. But it can also reach higher values up to 2.5 grams of carbon per kilogram of water. Well, the figure shouldn't look like that, but no problem. In the conclusive part of this short talk, plants can accomplish higher efficiency in lower and humid regions, up to 2.5 grams of carbon per kilogram of water, but the land cover characteristics can also reduce water use efficiency variability. In other terms, there is no linear relationship between both. As I show you, when geographic elevation increases, water use efficiency decreases up to 1 gram of carbon per kilogram of water, but vegetation type can also influence to make water use efficiency even lower. It has been shown also some positive relationships with droughts at short time scales, which are more likely to be observed. Short time scales translated in the indices I've been using. It's from SPI from 1 to 3. 1 to 3, it's related 2 months, 1 month to 2 months, 3 months, which are more evident in semi-arid climates because plants seem to respond faster to water stress. On the outlook part, it has some practical implications. For example, if we focus on nature-based solutions, those kind of ideas in order to overcome the issues of climate change and carbon uptake could have different efficiencies depending on the kind of plants, on the kind of vegetation, and on the kind of geographical environment that we would use that. At the sites evaluated in Bolivia, such is supported by a wide range found at all locations and the wide variability according to seasons. Among the conclusions, to finish this short talk, future applications should evaluate vegetation types, for example, individually, not to focus on trying to reforest areas only with a single species, but also it has to be evaluated the seasonal and interannual variability of this kind of solutions. So that would be all. Thank you very much for your kind support.
Thank you so much, Mr. Soria. If the auditory have some questions, please, we can to do 1 or 2, if you like.
Thank you for the talk. Quite interesting. I have just one quick one that was like when you were showing the SPIs in one of the slides, if there was a threshold that you can say, okay, from here to here, we can have certain conditions, or to say the severity that you were showing in some of the graphics, just to see, okay, from this point, going back to the lower values, as you were saying that they were like worse than the other ones. If you can say there is a threshold where there is like actions that we need to take or something like that regarding the SPI's values, for instance. Thank you.
Thanks. If we are talking about thresholds, which is what I understood from your kind question, well, I think it will depend on the region, and it will depend on the kind of land cover we will find in the region and on the geographical conditions as well as on the climatic conditions we will find in that part. I didn't analyze the aspect of thresholds at this time, but I could consider that for future analysis. And thank you for the interesting question.
Thank you so much. One more? Okay. Was interesting to understand the use of the Custris model and the result with the, for example, vapor pressure deficit, no? One small question about that you shared with us, maybe some ideas for share about why plants in semi-tropical, you say, areas produce more biomass and can consume less water.
Um, there might be some reasons. According to the original paper, for example, it would depend on the type of vegetation. The vegetation that in Espanol would be deciduous. I don't know in English. The kind of vegetation which is taller and which lasts along the seasons is the one that can take up higher values of water use efficiency compared compared to, for example, small shrubs and that kind of vegetation that you can find in the case of Bolivia in the Andean areas. That kind of vegetation then in the tropical areas were likely to be more resistant to drought conditions. That's what the original paper said about. And that's very interesting from my perspective for practical applications.
Thank you. Thank you so much.
Thank you.
Okay. Thank you so much. Maybe the next one, colleague. Is the colleague Rabia Sama. We have the online participation.
Hello, everyone. I am very honored and very pleased to be presenting within the sixth United Nations Conference on Space Technology for Water Management, taking place in Costa Rica from the 7th to the 10th of May of 2024. I am Rabia Samah Shukri. I am PhD candidate at the University of Oran to Algeria, and I will be presenting today my work titled Assessment and Monitoring of Soil Moisture and Drought Conditions in the Orani region, Algeria. I would have preferred to be physically present amongst you today, but due to personal circumstances, I couldn't make it. But I am still very, very grateful to the opportunity granted for me to present my work nonetheless. So my work is structured around 7 main axes. I will start by introducing briefly the research work, and then I will move to the research questions and objectives of the study. Then I will lay the foundation for the conceptual framework by quickly defining some concepts. Then I will introduce the study area and the methodology. Then I will move to the results section and finally to the conclusion. So the drought evaluation and monitoring are essential for determining the impact on agricultural land use, and on food production. In the recent 2 decades, the studies and the research around drought evaluation has increased due to the climate change that has been increasingly noticeable, and it is expected that the climate change, it is expected that it will worsen the drought's impact on agricultural land and thereby limiting crop diversity and lowering the productivity of this land. So one of the ways to evaluate and assess the drought conditions is the soil moisture study. So the soil moisture is a key variable in monitoring and even in predicting meteorological and hydrological droughts, as well as assessing crop and drought events. Advancements in Earth observation, in machine learning and remote sensing has demonstrated that it is feasible and it can be effective to assess and to measure the soil moisture content across the entire electromagnetic spectrum. And for this, several methodologies have been developed to support this endeavor. The main questions of this study are: how did the surface soil moisture values change from 2015 to 2022? And did the region witness a risk of drought? So the objective of this study is to define the surface soil moisture within the period from 2015 to 2022 using machine learning and Earth observation tools. The choice of method was based on the availability of data, the accessibility to this data, and it has also as an aim to assess the effectiveness of these tools in agricultural land and food security as a consequence, and on natural resources. So as a conceptual framework, we can see through the chart here that climate variations and drought events are interconnected. So the meteorological, agricultural, and hydrological and socioeconomic droughts are linked to the precipitation and to the temperature affected by human activity. The soil moisture is defined as the amount of water held within the soil particles and pore spaces, which is critical for plant growth, agricultural productivity, and hydrological process. So what is the significance of soil moisture in agriculture? Soil moisture is crucial for monitoring agricultural operation, forecasting natural risks, and managing water resources. So this data can anticipate further coming floods or water shortcomings or ahead of time, amongst other indicators. So what does soil moisture influence? Soil moisture influences air content, salinity levels, the presence of harmful substances, soil structure and depth, ground temperature, and heat capacity. Surface soil moisture, on the other hand, is the moisture content within the soil, stratum extending from 0 to 5 centimeters in depth. So this parameter constitutes a pivotal cornerstone for various hydrological, physiochemical processes within the terrestrial ecosystem. Our study area is the region of the Orani, which is comprising all of the northeastern Algerian municipalities. And the region is drought prone and is also known for its long-term drought due to low precipitation and its semi-arid climate. So the Orani is bordered to the north by the Mediterranean Sea along 400 kilometers long coastline, to the west by Morocco, to the south by Shergi and high plains of Sirsu, and to the east by Warsanis mountains and the Dawel Shalif Valley. So it is naturally made up of coastal and subcoastal plains, mountain range, inland basins and thus steppe zone. This region is also known for its agricultural production, and it is also known for a noticeable decline within the recent past few years. The methodology used in this study is structured in the platform of Google Earth Engine to provide effective monitoring of surface soil moisture in the time series from 2015 to 2022 throughout the SMAP global soil moisture dataset and the VCI index calculated from MODIS data. So the datasets used in this study are the NASA USDA SMAP and the MODIS data that I use to calculate the VCI index. So the VCI index is, or the vegetation condition index, is suitable for monitoring agricultural drought. It compares the current NDVI to range of values observed in the same period in previous years. The NASA USDA Enhanced Map Global Soil Moisture Dataset provides detailed information on surface and subsurface soil moisture, including measurements in millimeters, percentage profiles, and surface and subsurface soil moisture anomalies. So the two charts here summarize the code structure on the Google Earth platform for both the surface soil moisture process and the calculation of VCI process. So we start by the Google Earth Engine inputs, which are the MODIS and the NASA USDA SMAP data, and then we proceed to determine the timeline and the study area, and then we follow by different filters. So the filter is based on date, based on image collection, and based on mean to reduce the data. So both methodologies can produce massive data. So in order to reduce the data, we chose to filter by mean, and then the outputs of both processes is the mean values of both the VCI and the surface soil moisture in the time frame from 2015 to 2022. So the results of the surface soil moisture are indicated throughout this graph and throughout the values in the table. So the values are for each year. The results showed that the mean value of the surface soil moisture anomaly from 2015 to 2022 is 0.051, which is a negative value indicating a high drought in the study area. The lowest drought was registered in 2018 with a value of 0.516, and the highest drought was registered in 2019 with a 0.069 value. As for the VCI results, so they are also showcased in this graph and in the table values for each year. So as for the VCI, the mean value detected throughout the time series was 0.56, which suggests severe drought The results are consistent with the findings of other drought studies conducted in the Algerian context in the recent years, indicating that the northern region of Algeria is indeed witnessing an increase in drought risk. Further studies are needed to identify the effects and consequences of this drought on the agricultural land and food production in the Orani area. As a conclusion, the results demonstrated that the study area is witnessing a severe risk of drought and further showcased the effective, quick, and cost-effective use of Google Earth Engine platform in monitoring the drought risk. And thank you so much for your attention.
Thank you to our colleague Rabia. If you like to share online some questions, they are welcome. Okay, it's between us, Mamoudou. Yes, thank you so much, Mamoudou. Mamoudou Senghor is an environmental analyst at the National Early Warning and the Response Mechanism Coordinating Center in the Gambia. Thank you for being with us. Mamoudou shared with us the presentation, the effect of meteorological drought on crop yield in North Bank region, the Gambia.
Thank you very much. Hello. Okay. Thank you very much and good afternoon, everyone, for having me here. It's a pleasure to be with you here. I think you'll have to excuse me of the very tired face. I am still trying to recover from a very long flight. I've been sleeping all along, trying to catch up with the Cascadian rhythm with the change of time zone. My country is about 6 hours ahead of here. Right now, I'm trying to adjust to that. However, I will try to take you through my presentation on the topic as indicated, the effect of meteorological drought on crop yield. Already, the previous presenters have already mentioned the type of droughts that we have, their definition, and their different role as far as water management is concerned. On my part, I am just concentrating on one of the types of drought, which is meteorological drought. And this is in relation to precipitation, rainfall, the amount of rainfall that is needed over a given period of time in terms of average over a given period. My presentation can come. Okay. Yes, maybe I'll just use the opportunity while they fix my presentation. I am from a very small country in the western part of Africa. This country is about 11,300 square kilometers. It's a country that is, of course, landlocked in one way because we are surrounded in 3 parts by a country called Senegal, which is the part of the east, west, and north. Then on the Atlantic Ocean, we have our own border. But other than that, the Gambia is surrounded by Senegal on 3 parts, from the east, the south, and the west. This is a country that is so ironical. We have a river that runs across the country, about 400 kilometers, and almost divide the country into 2 parts. And then you wonder, why do we still have drought when the country is almost divided by river? But that is why I want to explain what we experience as a country. Oh yeah, moving. I think I have this, okay. Okay, in my presentation, I'll be looking at the introduction, the background, the research questions and objectives, as well as the results, the methodology I applied, and of course, the outlook of the research. As we all know, drought is a phenomenon that exists, and it is a slow onset, so its impacts cannot sometimes be felt immediately. but this is a hazard that affects almost a large number of the population in our country. And this is a country where we have 30% of our GDP is contributed through agriculture, and 70% of the employed workforce are engaged in agriculture. So agriculture is very important to us. And on my research, I am looking at 4 cash crops, that is early millet, sorghum, maize, and groundnut. These are the 4 main crops that we grow in our country, and some other vegetable crops and other things. But hope my presentation is not also affected by the Cascadian reading. It's trying to adjust to time, huh? Yes, the definition is just there. We have meteorological drought. It's a complex and natural hazard that is global in nature and has threatened the livelihoods of Gambia's most vulnerable population, specifically the region where I come from. And this is the region where I do this research for, which is the North Bank region. Is one of the 6th administrative region of my country. And he said we have only one rainy season that range from June to October. And between this rainy season, it is a very short period. We have a long dry season, which is sometimes an impact, where the country is mainly we depend on mainly rain-fed agriculture. We don't have much irrigation. All the farmers, most of them, 99%, depend on rain-fed agriculture. So in a country where you have only one rainy season and it lasts for only 3 months, and this is a problem. So the Gambia is particularly prone to drought due to its location at the southern fringes of the Sahara Desert. I just mentioned that the Gambia is surrounded by Senegal, and this southern part of the Sahara Desert is crippling in towards the northern part of the Gambia. If you look at the map there where I mark red on the map down, that is where the region that they conduct the study for. And this part is mainly affected by drought because of the crippling effects of the Sahara Desert that is running from the north. And we have about 10 rain gauge stations. The country is a small country. We have about 10 stations that cover the whole country. And the stations that I am looking at is in Terawan, which is the North Bank part of it. And North Bank is one of the 6 primary administrative regions, as I mentioned, with a population of approximately 21,000. Yes, 221,054 people. And among that, we have 2,255 square kilometers according to a 2003 census. Move on. Okay. The methodology we employed in this research is trend analysis, correlation analysis, and regression analysis. And in the trend analysis, we try to answer the questions: how has crop yield varied over a period of 30 years from 1987 to 2018? And also, how has rainfall varied over that period? Also, how has this rainfall affected the crop yield? That is the correlation and regression between these 4 cash crop and rainfall within the period that we conduct the study. The other methodology, we have the SPI, that is the Standard Precipitation Index. Somebody already defined that. We've looked at the range from less than, greater than 2, we said very wet, from 1.5 to 1.9, then from 1 to 1.49, moderate wet, then 0 to 0.99 to minus negative is normal, then -1 to -1.49, moderately dry, from 1.5 to 1.99 negative, severely dry, and from less than -2, we said extremely dry. And this one is it is used to provide early warning and severity as it is specified drought condition for each location, as well as for risk management. So the advantages of SPI are the use of longest time scale to approximate of groundwater and stream flow drought. However, the limitation of this index include the possibility of trend in precipitation and adequate observe of data during this period. This is the trend analysis of the 4 cash crop that we studied on. Early millet, we have late one, but I studied on the early millet, the maize, the sorghum, and the groundnut. In the trend among the years from 2006 for the maize, recorded the lowest, and around 1992 to 1994, that is 1993, it recorded the highest, which occurred around 2002. Also for groundnut, the rainfall data, the cash crop data for 2002 and 2018, we are challenged with data and which is always scarce in some part of our developing countries. So for groundnut, I was just able to get data from 2002 to 2018. And of course, this has affected the correlation and regression analysis between the groundnut yield and the rainfall patterns. And sorghum also is a type of cash crop that we grow in the region as well as early millet. Yes, this is the variability of rainfall over the period from 1987 to 2017, as I mentioned. So among these years, the lowest rainfall was recorded in 2011, which indicated a very severe drought. It has seen close to -2, which indicates a severe drought. And the highest was just recorded about 2-3 years after in 2015. So using this standardized, the result shows that the lowest rainfall, as I mentioned, was in 2011. And the results also shows years of below normal rainfall with respect to the standardized normally of a mean of 0. Somebody mentioned the threshold, but this one we just use a mean of 0 and a standard deviation of 1. So this is a correlation and a regression analysis. Correlation and regression analysis between these 4 crops and rainfall. And I'll just concentrate on the p-values, which explains the relationship between these these 4 crops and rainfall. For early millet, it explains 0.21, which is about 21%. And since it is less than 0.05, then my hypothesis is rejected. And it's the null hypothesis, it indicates that there is no statistical significance correlation between below normal rainfall and yield of the 4 major food crops. Then among the 4 is only that maize, which indicated a correct hypothesis for 0.03. That indicates that there is no statistical significant correlation between below rainfall and that. So the research is needed to fill the gaps, understanding the different types of drought in the region, because this research is mainly on meteorological drought. If you want to look at hydrological drought, you will have to consider soil moisture, and where we have data challenges. So the use of space-based technology will help in having access to soil moisture data and other data that we can use, temperature, and so on, to be able to determine the other factors that can affect crop yield other than only rainfall. Because the cash crop that we grow within a period can really depend on the rainfall that is available, but the other factors in terms of soil types, soil moisture, and other things could also be studied further. And this will help in planning for drought mitigation. It is important to understand that drought characteristics through drought analysis development of national programs can be informed by experience of regional drought management. So in conclusion, drought analysis over the area of studies vary between mild drought and moderate dry condition. Given that these are rainfall seasons and such, the condition might worsen during other dry seasons, reducing the risk. Therefore, impacts of drought of utmost importance and require great emphasis. So with space-based technology, it can help in prediction for future drought and help in policy development and decision-making for our developing countries. So thank you very much. That is what we have.
Thank you, Modu. If somebody have one question, too.
Yes.
Thank you.
Yes, ma.
Well, thank you very much for a nice presentation. This is Mandira Singh Shrestha. I
Mm.
come from Nepal. Um, I'm equally jet lagged as you are. too.
Yeah.
But regarding the comparisons that you made for the four different crops,
Mm.
you've used the rainfall data you mentioned.
Yes.
So, where did you get the rainfall data? Was that in situ data along with the satellite-based observations? So that's one question. And out of the four crops, I also noticed that only one crop, that is sorghum, that has an increasing trend versus the other three
Yeah.
that have a decreasing trend.
Yeah.
So would you also explain why that is so?
Thank you very much. The rainfall data used from this is from an in situ station in Karawan. That is the oldest station in the region actually, which is very sometimes challenging. And it is collected by the Department of Water Resources and stored locally in computers just like that. So access to satellite data is available, but this is through a regional block by the agreement where we have access to these things. It will help in forecasting for the rainy season. But that is the only thing that we use that particular data for. But as we speak, we are looking forward to developing satellite data and getting access to it also with some little bit of capacity building and so on needed. Yeah, but the data is from in situ data. That is data from a weather station that is recorded and sent to a central server, and that is where we can have access to those data. On the type of crops, I already indicated that the only accepted hypothesis is for sorghum, which indicates that there is no relationship between rainfall and its yield. But also, I mentioned that there could be other factors that affect the yield of crops other than only rainfall, ranging from soil types, soil moisture, and fertilizer. Because most of the people that are farmers there, we depend on these inorganic fertilizer, and its availability is sometimes very expensive for the local farmers, which they used to grow their crops. So other factors could be the reason for the decline of those crop yield. Yeah.
Thank you.
Yes. Nina.
Maybe I shouldn't be asking questions, but yeah. My question relates to the resolution you would need for soil moisture data sets. I think that relates to the size of the fields also that you have in Gambia. So maybe you can elaborate on that because there are global soil moisture sets that are available.
Yes, soil moisture data is just recently that we have been donated a station that is automated that can also have sensors of soil moisture that sends information by the Cima Foundation of Italy. If anybody have access to those ones, they help us with a station that monitor those things. But as we speak, that is very difficult to have soil moisture data in those areas. This is why the study just focuses only on rainfall, but we could have, in further studies, included soil moisture, which is, of course, available through satellite data and images that we can also explore in the future. Thank you very much.
Mhm.
Yeah.
Thank you. Thank you so much. Was very interesting read about the increase of productions, no, in some special during drought periods. And you say there is different types of drug in the region. Can you tell us about this
Different
kind?
types.
Yes. Uh-huh.
Yes, I just meant somebody just presented on all the four types, that is agricultural drought, hydrological drought, and the socio-economical. In 2011, we were hit by drought. That is according to the presentation. We have registered the lowest in the region, about 533 millimeters, which is quite very low. And what it led to is socio-economical drought, which is food insecurity, the absence of all these cash crops in the region has affected the population a lot. So that is the impact of meteorological drought leading to a socio-economical drought, which is the absence of one of the crops or two or more crops for consumption. And for hydrological drought also that could lead to soil moisture, and we are finding it challenging to have soil moisture data, as well as agricultural drought. Sorry. Hydrological drought leads to the subsurface and surface water bodies, and the agricultural drought deals with the soil moisture. Maybe further studies have to be conducted with the access to data from satellite images that can help in maybe expanding on the study. Yeah, but of course we are affected by socio-economic help.
Thank you, Momodo.
Thank you.
No.
Thank you.
Okay, thank you so much. I can see that our next presentation from Ghana with Bernard Michel Agwasi. That is a recent graduate with the Master in Environmental Engineering and Management from the University of Energy and Natural Resources. Welcome, Bernard.
Thank you.
And Bernard talk about the geospatial mapping and analysis of surface water. Thank you so much.
Thank you.
The floor is yours.
All right. Hello, everyone. My name is Bernard Ochre once again. Yeah, it's unfortunate I couldn't make it on site, but here we are. Let's go. Let's do this. All right. So can you all see my screen? Share my screen. Okay. Relax. Okay. All right. Okay. Please, can you all see my screen?
Perfect.
Yeah. All right. Let's do this. All right. So my name is Bernard Michael Akwesi from Ghana, and I'm here to present on the topic geospatial mapping and analysis. Oh, someone's right. Okay. I'm here to present on the topic geospatial mapping and analysis of surface water demand, abstraction, and water yield in the Tana River Basin of Ghana. This project was funded by the Regional Center of Energy and Environmental Sustainability of the University of Energy and Natural Resources. All right. An overview of water resources in my country, Ghana. Ghana has a land area of about 240,000 kilometers square, with three main river systems, namely the Water River System, the Southwestern, and the Coastal River System. And then the catchment area of where my study was conducted is part of the Southwestern Basin, which extends a little bit into Cote d'Ivoire of an area of about 15,000 kilometers squared, sorry. In Ghana, river basins serve as critical sources for various uses, including human consumption, agricultural consumption, and industrial consumption. Now, why this study? The Water Resource Commission of Ghana over the years have stated that the Tana River Basin is one of the most exploited water-stressed basins over the years, and it is posing a threat to effective management of its water resources. Again, the Water Resource Commission are also saying that the Tana Basin is facing increasing demands due to factors like population growth, agricultural expansion, urbanization, and it is resulting into potential water stress among different water users. Unfortunately, the existing studies are limited in providing a holistic evaluation of water stress, considering factors like population growth, agricultural practices, industrial activities, and climate change impacts. With these being established, my main objective was to comprehensively assess and to spatially analyze surface water dynamics, including demand, consumption, withdrawal, and availability in the Tana River Basin of Ghana. Specifically, to conduct an inventory and mapping of water abstraction among different water users in the region. Secondly, to estimate and map current water demand, assess its impacts, especially on projected climate changes on future domestic water demand, and also to determine the water yield in the Tana River Basin, and finally, identify the potential water stress areas in the basin. My study area has a bimodal rainfall season occurring from April to July, which is the primary season, and then the secondary season occurring from September to November. My study area also supports residential, agriculture, and mining needs. All right, so water abstraction is basically defined as the act of removing water from a particular source or natural source. And in order to achieve this objective, an inventory analysis was conducted at all the various sectors to ascertain how much is being abstracted based on factors like the pumping capacities, the number of pumps, and the pumping hours. Okay, these factors were used to, estimate how much is being abstracted from all these sectors. Okay, then the estimated values, as you can see from the graph, were then incorporated into the GIS software, also based on the GPS coordinates of all these abstraction points. And then a map for domestic, industrial, and irrigation water abstraction maps were then generated. And then finally, a total abstraction map was generated. As you can see, these are all the abstraction points in the Tano River Basin. And the pictures are clear indication of the inventory analysis we conduct with the help of the Water Resource Commission in Ghana. Water demand is simply the amount of water required by individuals, communities, industry for their various purposes. And then in order to estimate our domestic demand and industrial demand, the following equations were used. That water demand was also estimated using these following equations. It is widely accepted by professionals. Finally, again, water yield is water that is readily available for abstraction. And in order to achieve this estimation, the soil water analysis tool was used based on requirements like the DEM, the digital elevation model, the land use, land cover, soil map, slope, and then data and weather data, which is precipitation, and temperature from NASA power. All right. And then the model analyzes water yield using this equation below, as you can see here. The water yield for each sub-basin was further multiplied by each sub-basin to get the actual volume of water yield in all the sub-basins. And interpolation was also incorporated here to get the total volume of the entire basin in general. All right. And then finally, water stress is also defined as a condition where the demand for water exceeds the available supply for water. And then the analytical hierarchical procedure or process was used based on these criteria: the total water yield of the basin, the total water demand, the total water abstractions, and population. And as an AHP, as demanded from an AHP, a pairwise comparison metrics were done based on expert judgment and the calculation of weight. And then the GIS was used to do the standardization and the weighted overlay analysis. And then finally, with a consistency ratio of 0.6, which is very good for our analysis, a potential water stress map was generated. Okay, so the following figures and values are, results from the estimations and then mapping of water abstractions and demands, showing how demand and abstractions are distributed in the basin, ranging from very high and very low values. So for example, domestic abstraction in total was 4.8 million meter cube per year. And then the map is showing areas where very high abstractions for domestic is done. For domestic water demand, a total of 63.87 millimeter cube was reviewed. And then for industrial demand and abstraction, a total of 52.8 millimeter cube was reviewed. For livestock water demand, 1.8 millimeter cube per year was also reviewed. And then for irrigation, 151.41 millimeter cube was reviewed. In the estimation of total water abstraction, it was revealed that the agricultural sector is the highest water consumer, followed by the domestic and then industrial. And this findings corroborates with global studies that agriculture sector is the highest water consumer. And we came up with a total value of abstraction of 210 million meter cube per year. In the estimation of projected domestic water demand, the graph here is showing how domestic water demand is set to increase from 2030, 2053, and 2063. The regression analysis to ascertain the impacts of future climate changes and domestic water demand also gave these graphs showing that both rainfall and temperature will significantly affect water demand for both RCP 4.5 and 8.5. But comparatively, temperature will significantly impact domestic water demand very, 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 very high as compared to the rainfall, all right, based on their R squared values and then their P values. In the estimation of water yield, a total of 5.9 billion meter cube was estimated as, total water yield for the basin. And then the graph is showing the various water yield from 2012 to 2022. Yeah. And then the graph below too is showing how the various factors that contribute to water yield affect water yield. So it is obvious that the higher the rainfall, the higher the water yield, and then vice versa. And it also agrees with a lot of studies indicating that rainfall is a significant contributor or contributory to water yield. Yes, obviously, before any model can be accepted, it has to undergo calibration and validation. And then with our R squared values, we can all testify how credible my model is into the estimation of water yield. Finally, the potential water stress assessment also revealed that about 41.7% of the basin is approaching moderate stress, followed by 39.7% high stress, followed by 14.69% low stress, and then 3.84% very low stress. And a small significant amount of value is approaching a very high stress. So as you can see on the map on the right, other hand, are various districts that are approaching the various kind of stress levels in terms of water. All right. So to conclude, the study has revealed that or has called for the attention for sustainable agricultural practices to ensure the effective use of water in the agricultural sector. It has also called for the attention for immediate climate attention or action or mitigation to curb the future impacts of temperature on domestic water demand. And I think it also aligns perfectly to the purposes of this conference, where we need space technology for effective water management. So I think to conclude, I think it is obvious that these findings are very vital, and then further studies should be done to make it more impactful. With these, I think it's okay to conclude. Thank you very much. Thank you very much. Is there any questions? You're welcome to ask any questions thank you.
Thank you so much, Bernard. Maybe there is a question online or in the auditorium. Yeah, you like? Thank you, Mandir.
So, good afternoon, Bernard.
Good afternoon.
Yeah, thank you for your presentation. You mentioned that you have used future climate projections as well as the different scenarios, 4.5 as well as 8.5. So which data sets in particular were you using for the future climate projections, and how do you select the particular data sets for this particular study? Because there's
Okay, thank you.
projections that are available. So which did you find appropriate for the study?
Okay, so with regards to the climate data sets, I visited the climate change assessment portal, the CCAP, and then a bias correction is already correct, like the bias correction has already been done. Okay, so I selected that from using 22,000 as my baseline. Okay, and I selected these climate change for both RCP 4.5 and 8.5 to be analyzed. So I think that is where I took my data from, climate change assessment portal. That is where I got my data from to be analyzed for my domestic demand and its impact on its, yeah. Thank you.
Thank you so much. Maybe online I can see to Lonely Mambo. You have a question online? Can you open your microphone? It's possible.
Yes, can you hear me?
Yes, please, I can hear you.
Okay, great. My question is, it was actually for the previous speaker, but I just want to say for Bernard, it's a great presentation. Thank you so much for sharing that. Wonderful. But my question is for the previous speaker. I wanted to find out if sorghum is a staple food in Gambia. And if so, let's see, what is this? Okay, if so, considering climate issues, is there ever a concern of running out of this food source? And what is the mitigation plan?
Thank you.
Thank you.
Thank you.
Yeah, thank you. Hello.
We can listen.
It's on. Okay. Thank you very much for the question. I want to know the sorghum you asked is referring to the cash crops, but generally people grow it in small scales compared to the early millet. We use coos as our staple food, that is coos, but generally it is used using the early millet, and a portion of the sorghum is used. According to the research, sorghum does not, the low rainfall does not affect sorghum. So our advice or recommendation could be to shift our attention on crops that are drought resistance, that is the likes of sorghum and other crops. Those are the mitigation plans and recommendations as far as the research is concerned.
Thank you.
Thank you. Thank you. Bernard, is very interesting your idea to the urgency to implementing sustainable water management, no? And some strategies to address the water scarcity in the Tano River.
Yes, please.
I have a little question about how maybe you think help to the decision makers to talk about this inequity, in particular for the irrigation demand. What do you think?
Yeah, so as part of the study plan, yeah, uh, we will have a session with the WRC, review our results to them, and then we find a way to communicate the findings to them to help curb this situation, because the amount of water these agricultural people are extracting is very outrageous. So as part of the study plan, it is yet to be communicated to the Water Resource Commission. They are solely in charge of water resources in the country, so that from there we will see how best this study can help mitigate the outrageous use of water in the agricultural sector. Yes, please.
Thank you. Thank you so much. Well, it's interesting to find the different approaches and diversity in the types of these four analyses, no? Vapor pressure deficit, Google Earth Engine platform, assess and geospatially analyze surface water dynamics from the identification of information sources, such as data processing at different scales, basins, municipalities, crops. Indeed, each of the cases show us in this session the need to provide information with the least uncertainty and the appropriate methodology in each case. And with the main challenge to the correct proposal, the use of information to promote risk reduction in making decision. We hope in this session that the audience has inspired and connected the dots to continue with the new and innovative research that allows the solutions of these kind of global problems. Thank you so much.
Thank you too. Thank you for having me too. And I hope there will be a new and the next on-site session to have me on site. Thank you.
See you soon. Thank you so much.